Welcome back at C Squared. In this lesson we'll talk about two more important segments that come over a triangle, and the first one is what we call median, and the median is the segment that connects a vertex in fact, with the midpoint of the opposite side. So in this picture you see this BD, it's what we call a median. It connects the vertex B with the midpoint of segment AC, the opposite side. How do we know this point is the midpoint point? Because you see these two segments are congruent. In a triangle we have three medians, and all these three medians are concurrent lines. They intersect in a point which is called the centroid. And you notice here, like I said in the other picture, each point F is the midpoint, E is the midpoint, D is the midpoint of each side. So that's the reason we call those three medians, and they are concurrent, and the point of concurrency is called centroid. There is a theorem that comes with medians which says the centroid is 2/3 of the distance from each vertex to the midpoint of the opposite side. So let's see what that means in this picture. It means that AG, which is this segment, is 2/3 of AE. Also BG is 2/3 of BD, and also CG is 2/3 of CF. That is the idea of 2/3 of the distance from each vertex to the midpoint of the opposite side. So now we can extend this centroid theorem. In fact, it's very useful to see sometime more relationship between different parts of the median. So this is the starting point, which comes with the theorem I just talked about, but we have some other relationship. Take a look to this one. This one is talking about the rest of the median. You see this GE, it's 1/3 of the whole median. GD, the same story. This GD is the 1/3 of BD, the whole median, and obviously the last one, GF, is the same type of property, 1/3 of CF. And also, like I said, this is a very good way to see it, and we have one more relationship between these two parts of the median. Look at here, AG is twice GE. BG is twice GD, and CG is twice GF. If you remember this relationship, a lot of the problems are going to be a lot simpler today and whenever you need this property. Let's see this example where you have to find the length of BG and GE if AE is 24. AE is 24, that is the median. And BD is 18, that is also the median. So now let's take a look. How do I get BG? BG is this segment that connects the centroid. By the way, that point G is the centroid of the triangle ABC with that vertex B. And this segment should be 2/3 of BG. I just used the centroid theorem. Of BD, not BG, obviously. So now, do we know how much BD is? Of course, it's 18, so BG will be 2/3 of 18. So an easy way is to simplify here. 3 goes in 18 6 times, so BG will be nothing else than 2 times 6, which is 12. Let's take a look now to the other part, and we need to find GE. GE is this piece here, and if you remember, we do have a relationship that is very useful. GE will be 1/3 of AE. So in our case, GE will be 1 over 3 times 24, a very similar approach. 3 goes in 24 8 times, so GE will be nothing else than 1 times 8, which is 8. So very useful if you remember this relationship. Other than that, you will need to find AG and then subtract that AG from AE. Let's take a look to this example. Very similar, however different. In this problem, we need to find the length of BD. Oh, that is the median, and AE, that is the other median. If AG is 7, and GD is 4. So let's start with the first one. AG is 7, so that will be this segment here. It's 7. So that AG, if you remember, is 2/3 of the whole median, which is AE. So now we have 7, that is how much AG is, equals 2 over 3 times AE. So what can we do to find AE here? I will personally multiply by 3/2, because that will allow me to cancel out these 2/3. So AE will be nothing else than 3 over 2 times 7, that will be 21 over 2, which is a good answer. I will keep it in this format as a fraction. Let's take a look now to the second part, where we know GD is 4, and we want to find BD. If you remember, BD, I'm sorry, is the other way. GD is 1/3 of BD. So we're gonna replace GD with 4 equals 1 over 3 times BD. And for finding BD, I'm gonna multiply by 3 to cancel this 1/3. I have to do the same thing on the other side, and BD will be nothing else than 3 times 4, which is 12. So this problem is the inverse of the other problem. We know pieces of the median, and we need to find the median. In my next slide, you see in some cases you have to use your algebraic skill. You're going to have to solve some equation. So let's take a look in this problem. In the figure below, points R, V, and L are midpoints. That is important. So that tells us this H, this point H, is the centroid, and we have those relationship I just used in the previous problem. And we need to find the value of x, y, and z. And what do you notice here? We have HV and MH in the first part. HV is this piece, if you notice, and MH is this corresponding part, and all these guys together are nothing else than the median MV. But what is the relationship between these two guys? If you remember, HV is twice MH. So looking to expression we have the equation 5. I'm sorry, it's the other way. Twice HV, right, is MH. So we have 2 times 5 equals 3x plus 1. This is the equation, and I'm going to move down here, and I'm going to have 2 times 5 is 10 equals 3x plus 1. I'm going to subtract 1, and I'm going to have 9 equals 3x divided by 3, and we have x equals 3. And that's the first part. Now let's take a look to the second part, where we know HL, which is this part of the median, and NH, which is the second part of the median. What is the relationship between these two parts? Twice HL, the bottom part of the median, is H and the top part of the median, if you want to call it like that. So we're going to have here twice the y, 2 times y equals 12. 2y equals 12. How do we find y? Just divide by 2. And y will be nothing else than 6. And we have a last part of this problem, where we have RH, which if we take a look is this bottom part of the median, if you want to call it like that, and HT is the top part. I call this the bottom and top because looking to the vertex, in this case vertex T. And what do we know? That bottom part, twice the bottom part, RH, is the top part, HT. So what will be the equation? 2 times z plus 1 equals 3z minus 1. So let's take that equation here on the right and solve it. 2 times z plus 1 equals 3z minus 1. I will use distributive property here, and we have 2z plus 2 equals 3z minus 1. My next step will be to subtract 2z to get rid of this 2z. The same thing on the other side, and we have 2 equals z minus 1. We're going to add 1. And we end up with z equals 3 here. And like I said, you notice this problem, you have to use some algebraic skill to solve it. However, those relationships between these different pieces of the median are very useful. Now you move to the another objective of this lesson, where you can use your skills in the coordinate plane to find the centroid. Remember, the centroid is the intersection of the medians. So let's take a look if we can do something here. And my first thing that I notice just by eyeballing, is this the midpoint of AC? I think it is. And oh, this horizontal segment is the median, right? The median is the segment that connects a vertex with the midpoint of the opposite side. And now, if you notice here, I already have this point D. So I think I can do something like that. If you have a ruler, it's even better. Wow, in this case, I think I can see this is the intersection point for these two median. You do not need the third one. If you have two medians and you find the intersection point, you have the centroid. And in this case, we finish the problem. This is 2 and 1. The centroid is 2 and 1. So my point here about this problem is, if you have a picture, you may want to try this graphical way to get the centroid. Sometimes it works, sometimes it doesn't. Like in my next problem. You see here the picture, and you see that centroid also here. So you'll see in my next problem, I don't think that technique works. We're going to have to use some algebraic steps to find the centroid of this triangle. But I think we can still do some graphical approach. This is the midpoint of this side, BC. I can see the midpoint of the other side is right here, right? And I can see even this one. So I can draw these medians, and just by drawing two of them, do you remember what I said? We can get this centroid. The centroid is right here, and the third one will be also going through that point. The question is, how do we find them? We notice in this picture the centroid is not easy to be read. I mean, it's impossible, in fact, to read the y-coordinate. We can read the x-coordinate, in fact. Okay, so how are we going to do that? We're going to have to write the equation of each medians. So I'm going to start to, let me change the color here, this one. Okay, and this median has two endpoints. One is right here at 1 and 0, and this one is 7 and -1. So what is the equation of that line that goes through 1 and 0 and 7 and -1? My first thing will be to find the slope, which is going to be y2 minus y1 over x2 minus x1. We're going to need this form here. So in this case, if you label x1, y1, x2, y2, what do we get? We get -1 minus 0 over 7 minus 1, which is going to be a -1 over 6. Yeah, it does look like that. If you take a look to the picture, the slope is -1/6. And now we can write the equation of this line using this form, y minus y1 equals m times x minus x1, the slope, the point slope form. So what do we get here? Y minus y1, so we're going to take this point, I think it's easier, y minus 0 equals -1 over 6 times x minus x1, which is 1. So we have here y equals -1 over 6 x minus 1. We can leave it like that, or we can do the distributive property. But we're going to need this equation of this red line, so I'm going to box it, and I'm going to move to the next line. Okay, the next line is that green line, this one, which I think is very simple to get it, right? It's a vertical line going through these three here, so that will be x equals 3. So it's not that complicated. This is the green line, and we need to find the intersection with the red line. So basically the last thing you need to do in this problem when we finish is to plug that 3 in here, and we have y equals -1 over 6 times 3 minus 1, and that will be -1 over 6 times 2, and we can simplify here, and we have 2 goes in 6 3 times, is going to be -1/3. And the centroid in our case is this point, let me call it G, which has the coordinate 3, this x, and -1/3 this y. Okay, again we need some algebraic skills here to find this centroid. You can see the picture here, and you notice that centroid is right here, like I said. We're going to move to the second part of the lesson, where we're going to talk about another important segment that goes with triangles, and that is the altitude. The altitude is a segment from a vertex of a triangle to the line containing the opposite side. So if you take a look here, AD is one of these segments. You start from the vertex A, and this perpendicular on BC, we see that right angle. Okay, and then I said an altitude of a triangle can be inside or outside of the triangle, or it can be even a side of the triangle, and you can see that a little bit later. We have three altitudes for a triangle because you have three sides and three vertices, and they all intersect in one point, which is called orthocenter. This point here is called orthocenter. Now in my next slide you will see what I just meant. This is the orthocenter for a acute triangle. You notice the triangle is acute and the orthocenter is inside of the triangle. All those altitudes are inside of the triangle. But let's take a look on this one. This is what we call a right triangle. We can see the right angle here. Notice that the altitudes of these triangles are these two legs, AB and AC, and also this AD. They intersect in this point, A. It's the one of the vertex is the right angle of the right triangle. And we have another case, the last case. Look at here, the triangle ABC is this obtuse triangle, right? I wanna be sure you see it. This is an obtuse triangle. Okay, obtuse. Look at here. If this altitude is inside of the triangle, the other two are not. They are outside. These dashed lines, you see, they form a right angle here. This is perpendicular on BC, and the other one very similar. If you take a look, this CD, it's perpendicular on AB. They are outside, and in fact you have to keep drawing this line in order to get this point G, which, if you remember, is the orthocenter. So the orthocenter in this case is outside of the triangle because we have what we call an obtuse triangle. Let me be sure we can see that obtuse here triangle. So these are the three cases for the altitudes of a triangle. Let's take a look to couple problems. We have this problem where we have a triangle in the rectangular grid and we need to find the orthocenter. Okay, so remember, we need to draw the altitude, and my first one will be this altitude because this is a vertical segment. It's going to be perpendicular on this horizontal side BC. So this is one altitude, and now let's see if we can get another one that it's easy to be drawn and maybe we finish the problem fast. If you take a look to AB, you notice it has a slope of what? A slope of rises 2, run it's 1, it's going 2 up, 1 left. That is going to be a slope of -2. I'm going to do the reciprocal of this, and that will be -1/2, and I'm going to change the sign, and that will be 1/2. So now from this point C, which is the third vertex of this triangle, I'm going to draw a line that has a slope of 1/2, and that means I'm going to go 2 and 1, and you notice I already got the orthocenter, 2 and 1, and now I have the altitude if you want. So this segment you see here is the altitude, and if you keep going you can reach the other point. Okay, so now we finish this problem graphically. This point here G, which has the coordinates 3 and -1, is the orthocenter for us. One more time, very similar with the median. Sometimes you can get the orthocenter using your graphical skills if possible. And you see that in my next picture down here. Let's take a look, and this is my last problem for today's lesson. Again, I'm gonna try to draw the altitude of this triangle. Maybe we can get them, maybe we cannot get them. Okay, so let's try to look to this side BC. We have 1, 2, 3, 4, 5, 6, 7, 8. This is 8. 1, 2, 3, 4. This is 4. So we have a slope of 4/8 positive, right? And that means 1/2. I'm gonna flip it 2/1, and I'm gonna change the sign -2/1. So this is BC. So from here I'm gonna go 2 down, 1 right, 2 down, 1 right, 2 down, 1 right, and I have my first altitude. So it did work fine, this one. It's right here. Let's see if we can do one more like that, and maybe let's take the side AB. So for side AB, if we count, we have here 1, and then 1, 2, 3, 4, 5, 6, 7. So the slope of that line will be, of that segment, will be a rise of 7, run of 1, and it's going down from left to right, so it's going to be -7/1. We're going to flip this one, so we're going to get -1/7, and we're going to change the sign, and it's 1/7. So from this point C, I'm going to go 7, I'm sorry, so this will be a rise of 1 and a run of 7. So I guess I'm going to go 1 down and 7. 1, 2, 3, 4, 5, 6, 7. Yeah, in fact, look at here. That's I think is good. We have the orthocenter, I think. Graphically. So we are lucky one more time with this problem. We are able to find this orthocenter. It's right here. And that orthocenter G, what are the coordinates of that gentleman? It's going to be -7 and 5. Orthocenter -7 and 5. If that is not possible, you may need to use some algebraic skill. Write the equation of some lines, find the intersection by solving a system of equation. You can see that in my YouTube channel. If you enjoy this lesson, don't forget to click the like button and come back on C-Square to C-Square for more help. Thank you.